Hello and welcome back. So let's continue solving exponential and logarithmic equations. Okay, so here we have an equation 5 to the power of 4 minus x is equal to 7 to the power of 3x plus 1. So clearly this is an exponential equation. So let's take the logarithm, let's do the common log of both sides. So if I take the common log of both sides, I see that I would have log of 5 to the power of 4 minus x would be equal to log, and this is log base 10 because it's a common log, so log base 10 of 7 to the power of 3x plus 1. And so then, because I've taken the logarithm of both sides, and I know I can do that, and I know they have to be equal because exponential functions are one-to-one, and so are log functions. And so I know that now these two functions have to be equal to each other. But then I can use my power rule, right? And so I can take this power and I can bring it down in front, and that's completely equivalent. And so when I bring it down in front, I have 4 minus x. I'll put that in parentheses, times log of 5 is equal to 3x plus 1 times the log of 7. Okay, so from here, I remember, log of 5 and log of 7, these are just numbers. That's all they are. So I'll just distribute them into these expressions here. And so this would give me from here, if I distribute this, I would get 4 log of 5 minus x times the log of 5 would be equal to 3x times the log of 7, and then plus just 1 times log of 7. So that's log of 7. And so now I'll go ahead and just collect like terms. I'll get the terms, when I say like terms, I mean with respect to x. So I'll get all of my x's on one side and all of the ones without x's on one side. So I'm going to subtract this log 7 over to this side of the equation and add this x log 5 to this side. So when I do that, I'm going to get 4 log 5 minus log 7 is equal to x log 5, and I added that, so, and then plus 3x log 7. Okay, so then now what I'll do, and I'm just going to come up here and give myself a little extra room. So what I'll do here is I will just factor out the x from here, and so then my equation just becomes 4 log 5 minus log 7 is equal to, let me just come over here a little bit, give myself some room, is equal to now x times, and this would just be 3 log 7 plus log 5, right? And so now I can just divide both sides by this expression here, and I would get 4 log 5 minus log 7, and then all of that divided by 3 log 7 plus log 5, and that's got to be equal to x. And then all of this I can just put into my calculator, right? So I'll bring up the calculator here. I'll be careful to put in the right parentheses, and we'll put parentheses, and it would be what, 4 times, and then you have to say 5 log, right? And then let's see, it's going to be minus 7 log, right? And then I'm going to close these parentheses here, and you can see that working up here in this little computer calculator. And now I'm going to divide, so I'm going to divide by, and I'll put a parentheses again, and so here it would be 3 times 7 log base 10, and then plus, it would just be a 5 log base 10, close my parentheses here, and then I can hit equals, and I get 0.603, so we'll say approximately equal to 0.6. And so this is approximately my answer, and so that's how we solve that logarithm. So notice, the key thing here is to use the property of the powers on logs. Whenever the argument of the log has a power on it, you can just bring it down in front and multiply it. And that's really the key to extracting that power out of it being in the position of being a power. So you get this expression, down in front, and it looks more like a linear equation. So let's go try another one here. So let's see, down here, I have another example. And so here now we have log base 2 of x minus 3 is equal to 4. Okay, so how do we want to solve something like this? Okay, so in this example, we're starting out with a log, and it's log base 2. And so here now, what I want to do is think of this as, because these are one-to-one functions, logs are one-to-one, I can think of this as being like, saying 2 to the power of this would be equal to 2 to the power of 4. I mean, as a matter of fact, that's what the log means, right? And so what I can do is I can say, okay, this is saying, what do I have to raise 2 to get this expression here? And it's saying that the answer is 4. So in other words, we can just rewrite this as 2 to the power of 4 is equal to x minus 3. And then 2 to the power of 4, 2 times 2 is 4, times 2 is 8, times let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16. So yeah, I have 16 is equal to x minus 3. Adding the 3 to the other side, I'm going to get 19. And so that gives me x is equal to 19. And so we see that went very fast. That was really very, very easy to prove or to solve. And that's really all you have to do. Okay, so moving on to the next problem. Let's see here. What did I have here? Yes. Okay, so here we have another exponential equation. I'll go ahead and do this in orange. So here, these are exponential. So what do I want to do? Well, I want to take the log of both sides and do the appropriate one so that what I get is I can extract this algebraic expression out of that power. So one of the things I can do is I can say, well, look, here this is a 2 to the power of something. So why don't I take log base 2 of both sides of this equation? Okay, so if I do that, if I say log base 2 of 2 to the power of 3x minus 4 is equal to log base 2 of 15. Well, look, this is just 2 to the power of this, and I'm saying log base 2 of 2 to some power. Well, that's just got to be the power, right? So then this would then give me 3x minus 4 is equal to log base 2 of 15. And then I could add the 4 to both sides. That would give me 3x is equal to 4 plus log base 2 of 15, and then I could divide, and I could say, well, x is equal to 4 plus log base 2 of 15. And that's divided by 3. Okay, so now the problem that you have is you're going to have to express this in terms of a log that you can plug into your calculator, right? And so what you would have to do is you'd have to say, well, I'd use the change of base formula, and I'd say x is equal to 4 plus, and I would use, either base 10 or natural log, whatever you have on your computer. Most scientific graphing calculators will have both. So if I just do log base 10, then this would be log base 10 of 15 divided by log base 10 of 2, and then all of that divided by 3. So if you plug this in, you'll get x. Okay. Now let me show you, though, here's another way you could have done it. What you could have done is you could have said, you know what, I'm going to take the common log or the natural log of both sides. I'll do the common log for now because that's what I have on this calculator down here. So doing the common log of both sides, I would have just had, log base 10 of 2 to the power of 3x minus 4 is equal to log base 10 of 15. And now what I'll do is I will simply use my power rule. I'll bring this power down in front. And so this would give me 3x minus 4 times the log base 10 of 2 is equal to log base 10 of 5. And look what's going to happen. If I divide both sides by log base 2, I would be right back to where I was right here. Well, not right. No, let's see. Where would I be? Well, yeah, okay. So if I did that, I would have 3x minus 4 is equal to log base 15 over log base 2, and then I would just add the 4 and divide by 3, and that would bring me right back up to here. So you see there's actually more than one way of doing it. You know, you could do it either taking the log base 2 to begin with and then using the change of base formula, or starting with just the natural, or the common log of both sides and solving there. Also at this step, okay, at this step right here, let me just go over and give myself some room. You know, what you could have done is distributed that, and then you would have gotten 3x times log base 10 of 2 minus 4 times log base 10 of 2 is equal to, give myself a little more room, is equal to log base 10 of 15. Right? And then again, okay, so from here now, if I add this to the other side, I would get 3x log base 10 of 2 is equal to log base 10 of 15 minus 4 times the log base 10 of 2, right? And then I would divide by 3 log base 2, and that would give me x is equal to log 15 minus 4 log of 2, and then all divided by 3 log base 10 of 2. And this expression, you will discover, is exactly the same. Okay, and so there's a lot of ways to solve these log equations, and you know, no one particular way is right, except to say, you know, the most efficient way is the best way. But so you can see there's a lot of different ways to do it. So we've got I think one more to do here, and you know what, I'm just going to save that for the next video. So we'll come back to this one in the next video. See you then.